Well, welcome to Spokane Community College again. What we're going to be doing this morning is we're going to balance the rotating assembly. This is a 5.7 liter Chevrolet V8. It's an automatic transmission engine. And so what we're going to do is the rods, the pistons, weigh the rings and bearings. We're going to calculate the bob weights, set up the crankshaft in the machine over here behind me, and then we're going to balance the rotating assembly. The first thing that we want to do is make sure that we have all the parts and pieces here that are necessary for the balance job. We have all the parts here, the crankshaft's here. It's been reground to 10 undersize. We've got the flex plate, and we've also got the damper. So we might as well get started. One of the first things that I really want the students to do every time is do a complete job of working with this balance card. So what I'm going to do first is I'm going to lay out the connecting rods, and we're going to go through and we're going to weigh the rotating end of the connecting rod and record what each one weighs at the start. We're going to correct the rotating ends, and then we're going to write the correction down here and also total up that amount of correction. So when the customer receives the balance job back, he's going to receive one of these cards, a copy of it at any rate, that he can read and he can actually see what we performed on that balance job. So I guess the first thing is we're going to lay out the connecting rods. I like to lay these out in order, and I also want to make sure that both the pin end and the housing bore are clean. If they're not clean, it's going to affect the way that we hang these on the fixture for checking the weights, and that can interfere with us making things really, really accurate. These rods have been reconditioned. The connecting rod bolts and nuts are still torqued, and that's important. If you have a set of connecting rods that you're going to be weighing, make sure that the bolts are torqued in position. If they're a little bit loose, that's going to affect the weight. This is the fixture and the scale that we're going to be using in order to do the balance job. What we've got is we've got a bearing system here that centers the rod and also weighs it. Think of the connecting rod. When this is operating and running in the engine, you've got the large end of the connecting rod. It's rotating in a circle with the crankshaft. The pin end, however, is moving back and forth with the piston. So we've got a rotating weight here. We actually have a reciprocating or back and forth motion here. We need to isolate those two weights in order to successfully balance this connecting rod. Now, before I set it on the fixture, I want to make sure that the bearings on the fixture are clean. There's no lint or debris on them. That's going to affect the way that the rod hangs on here. The first rod that I put on, I'm going to use it to set up the hanging fixture. And what I want to do is I want to make sure that this chain is hanging vertical, and I just sight off of the post here. I also want to make sure that it's hanging vertical here and it's not being pulled one way or the other. A little bit of an adjustment I need to make here. Okay, now the connecting rod is hanging on there, let's say just in a free state. I take my finger and I hit the bottom of this counterweight, and what it does is it allows this roller to move back and forth into the housing bore, and it'll center the rod. Here we can read on the scale that the rotating end of this connecting rod equals 411.5 grams. Well, I'm going to record that over here on the balance card. So far, that's my lightest rod. It's the only one I've weighed. I reverse it so I know where that lightest rod is at this point. Now, as I go through and I weigh these other rods, for example, this one's 408.5 grams, Up 409 grams. I'll record that. That becomes my lightest rod. And I'm just going to go on down through the other 6 of these and record the weights. Well, we keep losing weight as we weigh the rods. Now we're down to 403.5. Well, gained weight here. This one's 415 grams. Hopefully you noticed when I set the connecting rod on the fixture, I'm actually using my fingers to repeat every time I put another rod on there so it's in the exact same position. And I use my right hand, thumb and forefinger as a bit of a gauge to center the rod on these bearings. I use my left hand thumb as a stop on the end of this Allen head, so every time I put the rod on that fixture or any other rod, I'm setting them in the exact same position. I think that's important, because what we're trying to do is we're trying to eliminate any possibility where excess weight can enter into the effect of how the engine runs as far as balance goes. So what I have now is I have the lightest rod identified. Excuse me. And this is 403.5 grams. So what I'm going to do now is I'm going to lighten the rotating ends of all 7 connecting rods to equal that 403.5 grams. Okay, this one has quite a bit of weight to come off. This weighs 412.5 grams or 412 grams. So, you know, we've got about 9 or so grams to take off of this. That's quite a bit of weight. Before we started this process, I took all 8 rods and just set them on the scale, and just to see how close they were in total weight. And in total weight, they were very close. They were probably within about 4 grams. But here you can see the rotating ends were off 9 or so grams from the lightest to the heaviest one. Kind of gives you an idea that, well, if we're trying to bring all of the rotating ends the same, we've got a lot of work to do. Then after we're done with that, we're going to do the pin end weight. So we're going to go over here to the grinder now. We're going to make a little noise, and we're going to bring these all to the same weight. Just got a little plastic container here with some water in it. I want to cool the connecting rod to make sure I don't overheat the thing, do any discoloration, or distort that housing bore as I'm grinding. Okay, now we've got all the rods weighed on the rotating ends, so now we need to correct them. We're going to do that on the belt sander right here. So before I correct them, I want to get some better eye protection on, because we're going to be doing some grinding. You're going to see some sparks, and we're also going to be making a little bit of noise. When I first started balancing these rods, you saw me simply put the rod on the belt sander, and I was sliding the rod across the face of the belt sander, turn the rod over, slide it across to rough this in, because we've got a lot of weight to take off this set of connecting rods. Well, after I get it down within a few grams of our final goal of 403.5 grams, then you saw me change my tactic where I was simply moving a rod in a little bit of an arc motion. And what that does is it finishes the rod off, so it's pretty nice appearing too. I mean, both grindings are very acceptable, but this just makes the customer think that you know, you really cared about the product that you're putting out. Okay, here we've got about 2 grams to take off. So I'm going to go to the finish type grinding on this one right now also. Okay, now we've corrected the rotating end of each connecting rod down to 403.5 grams. So I'm going to write that into the final here. I'm going to go ahead and add up what we had to correct now. So that first one we had 8 grams correction. Then we had 5.5. The third rod was our lightest one. So that's 0. The fourth rod, we went from 15 to 3.5, so that's what, 11.5 grams? Okay, the total correction on just the rotating end is 42 grams. And think of an ounce as little over 28, 28 1/3 grams to the ounce. And what we're going to end up talking about towards the end of this video is ounce inches of imbalance. Those are the tolerances we have today. So 42 grams, that's quite a bit of corrections on a set of connecting rods, just the rotating end. So what we're going to do now is we're going to correct the pin end. And in order to correct the pin end, it's a pretty simple method. We could switch this fixture around and rehang them this direction, where the rotating end is being supported by the chain beam, and then the pin end is being weighed. It's a lot quicker simply to weigh the total rod, and any correction that we need to make, we're going to do on the pin end. At the very end, what we're going to do to find out what that reciprocating weight is we're simply going to subtract the rotating weight from the total rod weight, gives us the reciprocating weight. Whichever way you do it, they both came out the same. For me, this is a lot quicker and easier to do. So here on the total rod, we've got a weight of 586 grams. Okay, 585.5. This is 585.5. This one's 588. Here we have 584. There's our lightest one so far. I'm going to invert it in relationship to the other connecting rods. 584, 584 and a half here. .584. Another 584. And 586 and a half. Okay, so we had a couple rods here that were 584. That's our lightest one, so we're going to correct the others to that weight. Our total weight now is 584 grams, and so I'm going to go ahead and write down the corrections here also. Okay, we had 6 grams. So the pin ends were pretty close. Rotating ends were pretty far off. And remember in the beginning I said that I'd weighed all the rods total, and they were all fairly close. So by correcting these rods, these were definitely a set of connecting rods that needed to be balanced. Now all I need to do is I need to subtract 403.5 grams from 584, and the reciprocating weight of those connecting rods, the reciprocating weight is 180.5 grams. We will need to do or know that figure for figuring the bob weight down the road here. Okay, so I'm going to take these connecting rods and set them aside, and we'll start with the pistons next. Something I wanted to mention about these connecting rods. When we balanced or we corrected these, the most we took off of any one of the pin ends was 2.5 grams, and that was off of the 8th connecting rod. It's become a practice of mine that if I have to remove more than 5 grams from the pin end, after I finish correcting all the pin ends, I'm going to go back and recheck the rotating end. Fulcrum points. We've all learned about those a little bit, but if you take too much weight off of this end, it changes that fulcrum point a little bit, and it'll actually make this end a half a gram, maybe a gram heavier. So kind of sock that away in your memory bank that if you take 5 or more grams off the pin end of a connecting rod or the reciprocating end, go back and reweigh the pin end. You might have to touch those up just a minor amount. Okay, so now we're going to go with pistons. And all I'm doing there is I'm laying them out 2 rows of 4 for the V8 engine. We'll go ahead and we'll weigh each one and record that weight. This one's 695, probably 695 and a quarter, because if you look at this scale, the half a gram light keeps coming on and then it goes back to 0 back and forth, so it probably actually weighs about 695 and a quarter. Here we had 696. $695 even, and if you notice, I turned that piston 90 degrees. That has become my lightest. This one's a little heavier, 698. Okay, we have the third piston. This was our lightest piston. And this was our heaviest piston at 698. We're going to try something here. All I'm doing is swapping the piston pins here to see if that evens them out closer. Did not. Okay, so the lightest piston I have turned 90 degrees, and what we're going to do now is we're going to go ahead and we're going to lighten these pistons to 695 grams. Now, in order to accomplish that, I'm going to use the lathe right here. When I go to chuck the piston in the lathe, I get in the practice of, I look where the front mark of that piston is. And what I'm going to do is I'm going to set this in the lathe so that that front mark's pointing towards me, and I want the skirt in alignment where the chuck key goes in. Because what we're going to end up doing is we're going to have this piston in and out of the lathe a couple of times weighing it, and I want to put it back in the same position so everything runs true. So we'll get the lathe set up here a little bit. Let me grab a tool bit. You might want to look at this tool bit a little bit. The way I've ground this tool bit is that the tip has got a little bit of a radius in it. I seem to like that better for machining aluminum than I do a real sharp point on it. I like to leave a little bit of a radius in there because it also, I think, keeps, eliminates any place where maybe a fracture or a crack to develop. Now what I'm going to do to machine the piston is I'm going to set the automatic feed so it goes from me towards the middle of the piston. I don't want to feed out and maybe get into the piston skirt too heavily. Just kind of a safety precaution and also damage control. I keep an eye on how many thousandths I feed this in, and right now we're only taking off a total of 10 thousandths of aluminum from the balance pad area of that piston. That's going to become important, so you figure out how many thousandths to the gram, or how many thousandths to the half a gram. Okay, we're at 595 on that one by removing 10 thousandths material. We only have to take off a half a gram on this one. Okay, now here I'm putting that same piston back in, and this way it's going to run true if I match the way that I had removed it. Okay, this is the last piston. Remember that one that I only had a quarter of a gram to take out of? What happens if I would have taken off another gram instead of a quarter and gotten too light? That's when integrity comes into play. You got to go back and you lighten the other ones to match it. Okay, so we got the pistons done. Now we can go on to weighing rings, the bearings, and calculating the bob weight. Okay, we've got the pistons balanced, the weights recorded, so I'm going to put these back in the box, and then we're going to go ahead and weigh the piston rings and also the rod bearings. Okay, the rod bearings weigh 46 grams, so I'm simply going to write that down here. I'm still old school. I don't like to touch the bearing surface with my fingers and leave a print on it. And we're going to weigh one set of rings for one piston. And the weight of that set of rings is 58 grams. Okay, and after balancing the pistons, both ends of the connecting rods, weighing the rings and weighing the bearings, now we can go ahead and calculate the bob weight here. So let's transfer some of these weights over. I've written here the weight of the rings times 1. The weight of the rod bearings, we've got to do that times 2. Okay, the weight of the pistons from here. What I'm going to do, that's the piston and the pin. We don't have any pin locks. This isn't full floating, so I'm just going to kind of bracket that and put in 695 grams. And then the reciprocating end of the rod, that comes from this figure right here, reciprocating rod, 180.5. The rotating end of the rod was 403.5. So that would be 807. We have to multiply the rotating end of the rod by 2. We also have to multiply the rod bearing by 2 because we have 2 rotating ends of the connecting rod and also 2 sets of rod bearings on each journal. We're going to talk about balance percentages, and what we do with all V8 engines is 50% balance is what we call it. It's 50% of the reciprocating weight, 100% of the rotating weight. So we've got right here, these figures are 100% of the rotating weight that are going to be on the crankshaft journal when it's operating or running in the vehicle. We're taking half, or only 1 piston and pin, 1 set of rings for reciprocating weight, including the reciprocating end of the rod. Okay, and the oil allowance I'm going to put down here is 3 grams. And what we need to do now is we need to total these up. So what have we got here? We've got a 0.5. So we've got a bob weight of 1,835.5 grams. And now what we're going to do is we're going to make up some bob weights that equal this amount. And this is what we're calling a bob weight. We've got 4 of these for a V8 engine, and what we're going to do is we're going to make those equal 1,835.5 grams by using different weights of washers. These particular washers are 20 grams apiece. These thinner large diameter washers are 5 grams each. These small blue washers are 1 gram apiece. And then we have some small thin washers that are only 1/2 gram each. So what I'm going to do is I'm going to count out, well, let's go with like 15 of these just to start with. And when I'm making up this bob weight, I make these two stacks right next to each other. Because I want to make sure that I have the exact same number of washers on both of these stacks. Here we have 1835 and a half. For demonstration purposes, this kind of sucks because this is pure unadulterated luck. We wanted 1835 and a half. I guessed at 1520 gram washers. That's not skill. And we're at 1835 and a half. Now, we may need to work with these other washers on the other three bob weights. But I got to tell you, that's luck. Well, we'll go with 15 on each stack this time and see if we're just as lucky. We're at 1836 and a half. We've got some work to do here. So I'm going to remove two 20-gram washers, and now I'm going to take three 5-gram washers, and I'm going to put one of those, or three on each stack here. Let's try 4, see just what happens. 1835 and a half. Okay, we have a half a gram calculation here that we're trying to come up with, 1,835 and a half grams. Well, so far we've been extremely lucky. We've hit that number right on. You won't always do that, and this is what I say. You want to hit the number exactly or be a half a gram over. I'm going to say it's critical that each stack of washers have the same number on them. Now, I could have 1,835 and a half grams, but what happens if I had one of these washers over here? So this actually has, 2 extra washers, this has 1 less washer or something like that. You can still have the right number of grams, but if you have more weight on one side than the other, that's going to affect your balance job in the machine. So, we've got the bob weights made up now, and now we can go ahead and set up the crankshaft.